If we're going to factor this, you could try multiplying 81 times 4 and get a really big number. Not a smart move. You could look for a GCF. There isn't one. But what I notice is, hey, if I look at these two values, I notice they're squared. So this is going to be a trinomial with squared, so it's a perfect square trinomial. Let's check to make sure it is. This first piece, you would notice, to get this, it's 9x times 9x. To get a 4, that's 2 times 2. Now if I simply take these two values, the 9x and the 2, multiply them and double it. If I take those two values, multiply them and double it, so it's 18 times 2 is 36 x. If this matches the middle, we can proceed with the shortcut. If it doesn't, we just stop. We can't factor. As long as these are squares. It does match. Yay! So what we do is our answer is going to be something squared. That is a minus, so this is a minus. And you simply take these two pieces. The 9x is your first piece. The 2 is your second piece. And that is called factored form. That's 9x minus 2, 9x minus 2. Two of the same factors. Perfect square trinomial. Number 2 is not a trinomial. It's a binomial. But it also has squareds. There's no GCF. First check for that. It has two squareds. It's called a difference of squares because there's a difference of two square values. So the first one is 11x squared. The second one is 8 squared. There is a minus between, so we can proceed. The answer is actually fairly simple, if you can remember your process. You put a plus and a minus, and you simply just take the 11x and the 8. So it's 11x plus 8, 11x minus 8. And you are done. That's called a difference of squares. This is called a perfect square trinomial. Here, you go, oh, it's a square trinomial. No, it's not. Those aren't squares. But there is a GCF. Yay! Pull out the 3, the GCF. When I pull that out, that minus is going to be right there. What values, when you pull out a 3? Well, if you pull a 3 out of this, 3 times x squared is 3x squared. 3 times what is 75? Well, that'd be 25. But you might think we're done, and we could be done, but this can factor still. Now, could I use this method? Put a 0 on the bottom? Yeah. But that's the answer. X minus 5, x plus 5. That does work. Okay? X minus 5, x plus 5. Don't forget your 3. A lot of people forget it. But could some of you notice that's a difference of squares? Can you notice that's an x squared and a 5 squared? X minus 5, x plus 5? It's this method again? Either way, it's your call. The last problem, is there a GCF? No. Are these end values squared? No. Okay, we have to fall back to our other method where we multiply these two numbers, the 5 and the negative 8, and you're going to get negative 40, and bring the 18 down. What two numbers multiply to get negative 40 and add to get 18? I'm seeing a 20 and a 2. And I believe this one's going to be negative. This times this is negative 40, this plus this is 18. So I got now x plus 20, x minus 2, but we're not done. You've got to wipe it off. You have to divide by the 5. It's just a cool little method where you take the number in front, the a value. Once you multiply it in, you have to divide it back out. 20 divided by 5 is 4. This does not reduce, so it takes a little trip up. And that is factored form. Now, this method It's kind of weird, but it's very quick and useful. There are other ways of factoring. This is just kind of cool. Again, you multiply front and back. That comes down. What your numbers multiply to get this, add to get this. And then you take that a value, divide both, because you have to divide it back out since you multiplied it in. Reduce, and whatever remainders or denominators are left, you bring up front. There you are. Make sure you learn all these types of factoring techniques.